So, as we get started, hi. Okay, so as we get started, you look all snazzy. Are you going to court?
No.
I see you're all like, I'm going to court. You're not, Alex. Where are you going?
I don't know. I hadn't worn this shirt with this blazer yet, so
It works. Don't you think it works? Good job. Okay, so I was just messing with him. People are always like, "Are you going to a job interview?" I'm just like, "Well, I'm a redneck." We just like, "Are you going to court?" That's how people in my redneck town would dress up. Okay, so let's talk about. You guys are going to have a quiz on Friday, and I want to tell you what your quiz is going to be like, so you can prepare for it. Okay, it's going to have just a couple of skin questions, maybe 2 or 3, which is what we're going to do today. But it's going to be mostly muscle. Only this time I'm going to approach muscle slightly differently. I'm going to try to combine the muscle mechanics that you learned from me and the muscle memorization that you learned from lab. So if I say a muscle is attached here, specific point, and does this, you tell me what muscle it is, right? Or if I say this is a muscle that does this action and give you a list, right? You can use both your logic and your memorization to figure out which muscle it is. Does that make sense? So what I'm trying to get you guys to do is to put together the logic that you understand and the memorization that you're trying to get over, right? And by the time you have both, then I really think that you're ready for the muscle portion of your lab practical. Until you have that, you're not going to be ready. So that's how I'm going to quiz you. And if you don't have it, remember quizzes count very little, but it like gives you, like you're taking your temperature as to how you're ready. And then of course your lab practicals start not next week, but the week after. Yeah, so you got a lot of time still, right? So if you tank it, worth very few points, and then you know, right? And then you know what you need to know. Does that make sense? Now everybody is finished with muscles, right? You've all done both appendicular and axial, and you got a little review time. FYI, a couple things before we go on. Make sure that over the course of the time before your lab practicals come, you are going to open labs, you're not missing your labs. That time, that reinforcement is really important. And the yahoos who have never been to a single open lab, when are they going to go? No, they're going to go right before the lab practical, right? And you don't want to battle with all of them because they don't know what the hell they're talking about anyway. They're like, I literally have been to lab twice this semester and now I need everybody to help me. So I would like to I always like to front load my knowledge, right? So I can be lazy in the end, get it all done super early, right? Try to not take the final exam. In this situation, try to get all of your lab studying done as early as possible so that you don't really have to compete for the cadavers, the material, or all that kind of stuff. That's what I would do. I mean, do whatever the hell your schedule allows, but that's my pointer. Okay, so everybody clear? Quiz? Okay, so let's start on integumentary system. Why am I doing chapter 5 all the way after this other stuff? Because you don't need very much help from me on chapter 5. It's not very hard. I think there's only maybe 2 questions max on your lab practical on chapter 5. So by moving it, it allowed me to be doing muscles in lecture when you were doing muscles in lab, and skeletal system in lecture when you were doing skeletal system in lab. So this is pretty intuitive. It's not a ton of memorization. The logic makes sense really easily. So we're going to do this. And it'll be, of course, on your second test with muscles. Okay, so integumentary system, which is chapter 5. So you can approach the skin or think of the skin 2 different ways. You can think of it as an organ or an organ system. So in order to be an organ, you have to have what? More than one type of tissue, right? And so the skin counts as an organ, even though it's counterintuitive, because it's got at least 2 layers, right? And so you guys tell me, especially if you missed it on the last test, if I ask you the layers of the integument or the cutaneous membrane, but this time I'm going to ask you from deep to superficial. What are the layers of the cutaneous membrane from deep to superficial? Deep. The tissues that make up the layers of the cutaneous membrane from deep to superficial. Go ahead.
So, adipose?
Adipose is actually not part of the skin.
Oh,
It's subcutaneous.
Oh, okay.
Okay, so go up one. That's not a tissue.
Non-keratinized.
That's superficial. Let's keep going. Areolar and or? Nope. Dense irregular. She's got it. Good. Areolar and dense irregular is what makes up the dermis, right? And then move up to the superficial layer. And now say that again. Keratinized stratified squamous epithelium, right? That makes sense? Okay. So those are the layers. Now, Cora was right about the subcutaneous layer is mostly made of adipose and areolar, right? But FYI, that's actually not part of the skin. It's actually subcutaneous. It's below the skin, okay? So now let's talk about the skin just generally, the cutaneous membrane. So since it is an organ, and we're going to get into the details of it in a little bit, it is the largest organ in the body. The only one that's even close to it is the liver. Are you surprised at how big the liver is? Yeah. We're going to go through it in excruciating detail today. That was just an intro. Okay, so the skin is the largest organ in the body. Were you guys surprised at how big the liver was when she actually got into the abdominal cavity? No? Oh, well, you weren't, because you're like, oh, yeah, my husband. It's enormous to me. So the liver is huge, but the skin is bigger. So the skin weighs between 6 and 9 pounds. And I'm not talking about the subcutaneous layer. I'm talking about without the fat. So depending on your body size, like your height, right, your width, it weighs between 6 and 9 pounds. And if you stretch it out, which is kind of gross to think about, but it's been done before, if you stretch it out, it covers about 2 square meters of surface area, right? And that makes me think of Silence of the Lambs. Doesn't it make you guys think of that? Right? Yeah. It puts the lotion on its skin. So you guys not seen that? All right. Like a couple of us oldsters, they're like, yeah, I've seen it. So it covers about 2 square meters of surface area. Of course, if you're much bigger, if you're Shaq, it's going to cover a lot more area. If you're teeny tiny, it's going to cover a little area, but it's still a lot. And 6 to 9 pounds, and it varies in thickness really dramatically. So the thickest skin on your body is about 4 millimeters thick. Here's thin versus thick skin. So here is thick skin. It goes all the way from here. And this is just the epidermis, and then you're going to have about the same thickness of dermis. The dermis is actually a little thicker usually. And here is thin skin. Primarily the difference between thick and thin is the thickness of the epidermis. Okay, so here's thin. It goes from here to here is the epidermis, and then here's our dermis that we're seeing down here. Okay, so where on your body, this one's easy, do you think the skin is thickest? Palms of your hands and soles of your feet, yeah? Where on your body do you think your skin is thinnest? Yeah, eyes, lips. So the first place you get wrinkles, that's where your skin is thinnest. That's where you have the thinnest dermis and the thinnest epidermis, right? You actually tend to dry out there, you lose your collagen fibers there. So around your eyes and around your lips is where you're gonna get your wrinkles first. So just something to look forward to. Usually starts in your 30s, unless you're living hard, and then you can hit 27 when you start getting your first wrinkles. Okay, so it is composed of 2 layers, an epidermis and a dermis. So let's look here. So hold on, right here. Epidermis from here to here, right? Okay. And remind me, what kind of tissue is that made of? Keratinized, stratified squamous epithelium. And then the dermis is made of a combination of 2 tissues, and that is areolar connective tissue and dense irregular connective tissue. Okay, we will get primarily just about the epidermis today. Next time we'll get to the dermis. Okay, so you should be able to, in this simple figure, be able to tell really easily epidermis, dermis, and when you start seeing a whole bunch of adipocytes, right, then you're in the subcutaneous layer or the hypodermis. Does that make sense? Okay, so subcutaneous layer or hypodermis. Now, the thickness of the subcutaneous layer is going to vary really dramatically depending on where you're looking, right? Also depending on how heavy you are, and also depending on your sex hormones. Your sex hormones will make fat be deposited in different patterns, right? So primarily, one of the primary differences between a pre-adolescent and a post-adolescent body is body fat deposition. And body fat deposition occurs entirely differently in the presence of estrogen, high levels of estrogen, and the presence of high levels of testosterone. So before we even get to this, what do you think? High levels of estrogen will start to make you deposit body fat where? Hips, breasts, but not very much around the middle, right? Comparatively speaking. So you get that shape, right? And in males, where does high levels of testosterone? Yeah, it's here, up. Skinny little twig legs, right? And here up, right? And of course that gets, right? And then it'll change again as you get older. You just become, your bodies go back to being very similar as you start to lose your sex hormones again. Go ahead.
In like survival mode, like hunter-gatherers, do they have less fat under like in the like?
Well, it's hard to get enough nutrients to store excess fat. So they think that before the agricultural revolution, your body fat percentage tended to be relatively low. But it's also super variable by season, because what would you do if you like had a history of starvation, right? And then you found like, oh, I've found this incredible fruity tree and this enormous chubby animal. How much of it would you eat? Just all of it. Like Thanksgiving, right? How many mashed potatoes are enough mashed potatoes? All of those. That's enough mashed potatoes, right? That's how I feel about mashed potatoes. There's never been too many mashed potatoes in the history of ever. There's just mashed potatoes for later, right? Those are later mashed potatoes, and these are now potatoes. So that's a good question, actually. Okay, so now why does it get to count as an organ system, too? Because the skin plus all of the accessory structures make it into an organ system. Now, the accessory structures include the erector pili muscles. You remember what those are? Make your hair stand on end. You got sudoriferous and sebaceous glands. What's sudoriferous? Sweat and sebaceous? Oil. You've got blood vessels and nerve endings and all of that stuff. So if you look here, you can see that now with all of that extra stuff, it can count as an organ system. Now, FYI, for me, I don't ask you pretty much anything except like maybe that's an erector pili muscle, because you can tell, about accessory structures. Is it because they're not important? No, it's just because I need that time, right? I need to use that lecture time for instance, cardiovascular anatomy, right? And if you had to guess, something had to go somewhere. So I don't really ask you about accessory structures almost at all. Question before we move on. Are sweat and oil glands considered endocrine or exocrine? Exocrine, yeah. Okay, all right, so now before we get into the specific structures, I want to talk about the functions of the skin, because mostly when we think about skin, we think about aesthetics, right? And we don't think about it at all until you hit adolescence and it starts being bumpy or oily or weird, right? And then you hit your 30s and then it starts being saggy and wrinkly and depressing. But other than that, we don't really think about functionality of the skin. So what I want you to do is to think, as I'm going through this, think about a burn victim who has third-degree burns over 60-70% of his body. And I want you to think about the ways in which that person is at risk for disease or death, right? So what we are going to do is we're going to look through this and we're going to get an appreciation for the functionality of the skin. So the first thing that the skin does for you is that intact skin with its intact layer of keratinization is passively protective. It is passively protective against microbial invasion, right? So an intact skin with keratin, and by the way, the cells are stuck together by desmosomes. So the combination of like a keratin waterproofing layer with cells that are stuck together by desmosomes, it's kind of like painting yourself with clear nail polish, right? Is it impossible for things to get through? No, but it's unlikely. So unbroken skin is a really good physical barrier. If that doesn't make sense to you, think about where you get skin infections. You don't get them where nothing happened, right? You get them where there was a nick. Now, are there pathogens that can get through intact skin? Yeah, there's flesh-eating bacteria. Thank heavens those are not more common than they are. But mostly it's a good physical barrier. In addition, it does some things that are a little bit more active for you. So your skin actually has secretions that it secretes onto the surface that are slightly acidic, which is inhospitable to a lot of bacteria, right? So that's a more active protection. That's why if you lick your skin, don't do it, it makes you look weird. But that time that you did, is it kind of tangy? Salty, right, because of sweat, but also kind of tangy, right, because of the acid, okay? So, and don't lick anybody else's skin unless you ask. Consent's very important. The skin also contains immune cells. So not everywhere, but in some of the deeper layers of the epidermis and all the way through the dermis and the subcutaneous layer, there are white blood cells or macrophages that, if anything managed to get in, usually you would scoop it up before it got even deeper, right? In addition, your skin also protects you from yourself because you have abnormally dividing cells, precancerous cells that occur in epithelial tissue all the time. And a healthy immune system, those cells will say, you look kind of funny. You look kind of like somebody I know, but I think I'm going to take you down, right? So it'll take you out when you start dividing abnormally and looking weird. So it protects you from pathogens and also from yourself. Which is why immunosuppression disorders tend to increase risks of cancer as well, because your immune system is supposed to protect you. Go ahead.
So about cancer, what about sun?
Yeah, and we're going to talk about UV. Hopefully we'll get to the UV part today. If not, we'll get to it next time. Your skin also protects you from mechanical damage, which seems kind of dumb to say, but really what I have is a layer of dead cells on the surface that I can rub up against anything and not actually lose any living cells, right? If I just rubbed up against it with a muscle, right, you'd cause damage to actual living cells. And then your skin will protect you from UV radiation, primarily because it produces a protective protein called melanin, which we'll talk about today, I hope. Okay, your skin also does both excretion and secretion. Do you remember the difference between excretion and secretion? What is it?
Excrete is like when it leaves your body.
Mm-hmm.
Secrete is like when it goes through.
Yeah, it's kind of, it ends up being like that. So excretions tend to leave because they're waste products. Secretions tend to stay because you made them on purpose, right? And your skin actually does both. Your skin actually both secretes and excretes. For instance, the acidic secretions that it makes, you made on purpose to protect yourself. But you also excrete waste products onto the surface of your skin. Has anybody ever been to an old folks' home and smelled what their skin smells like? It smells like medicine, doesn't it? It smells like medicine breakdown because they are actually excreting the breakdown products, the waste products of their medicine onto the surface of their skin. But if you've never been there and you're not from Utah, you might know about going on a tequila bender. What does your skin smell like the next day after a tequila bender? Tequila and bad decisions and regret is what it smells like, right? That's what it smells like. You're excreting it onto the surface of your skin, and it's really fragrant. And tequila has a lot of oils in it too, so it just excretes onto the surface. The last thing you want to smell in the morning is exactly what you're going to smell. What? Exactly, and then the smell is like, I think your body's trying to teach you something. But when you're 21, you're like, I don't even hear you. I don't know what you're talking about. Stop bothering me. So yes, you excrete it onto the surface of your skin. And then your skin also does body temperature regulation. Your skin helps with body temperature regulation, both because intact skin is like closing the doors on your house, right? Just a passive body temperature regulation. And then it does more active body temperature regulation by doing vasodilation to the surface and vasoconstriction to the surface. So let's think about how vasodilation can help with body temperature regulation. You will vasodilate and send more blood to the surface of your skin when you are what? Hot or cold? Hot, yeah. Now, how does that work? What it actually ends up doing is my body core temperature is heating up, right? And what I need is air conditioning. But in this situation, it's really fluid conditioning, right? I'm really cooling down the fluid, not the air. So what I do is I take that hot blood and I send it to the surface of my skin, and then cooler air blows by, and it's like blowing on soup, right? And it cools down the blood, and then I take that cooler blood and I circulate it to the core, right? And then I do it over and over again. And that's how vasodilation can help you cool down. In addition, the vasodilation to the surface also will activate your sweat glands, which, the water will actually break hydrogen bonds and can cool you down as well. So both of those happen simultaneously. And then the other thing is that if you are really cold, what you need to do is you need to do what to the surface of your skin? Vasodilate or constrict? Constrict. And what's the idea there? The idea there is that if body temperature is being lost, what I need to do is lose less heat, but even more importantly, I need to keep a disproportionate amount of the warm blood near my vital organs, right, at the core. So what I do is I vasoconstrict to the surface. I send less blood than I otherwise would to the surface, which what happens to the color of my skin when that occurs? it becomes more pale. And if your skin is really dark, you won't necessarily see it in the surface of your skin, but you can see it in your lips and the beds of your fingernails, right? And it can cause what's called cyanosis, which just means your skin is slightly blue, or portions of your skin are slightly blue. And the idea there is, if I have to keep something warm, or if I'm snowboarding and I have an accident and nobody can find me and I need to stay alive, would you rather lose a liver or a finger? You'd rather lose a finger. So you're going to get frostbite potentially at the periphery, but not at the core, right? And you keep those things. Does that make sense? Now, cyanosis, FYI, doesn't always have to do with vasoconstriction. It could also mean that your respiratory system is failing, so you don't have any oxygen in your blood, right? Or your cardiovascular system is failing, so you're not having any blood pumped to the regions. But cyanosis can be because of vasoconstriction. Okay, and then sensation at the boundary of a human or any organism is a great place to sense touch, temperature, pressure, pain, right? So you got a lot of sensory receptors there. Vitamin D synthesis. So your skin does vitamin D synthesis when exposed to a little bit of UV radiation. And so a little bit of UV radiation, you make vitamin D, you actually finish it in another organ, but we don't have to worry about that. And vitamin D is for a lot of things, right? Calcium is for a lot of things. Vitamin D allows you to absorb calcium from your diet, okay? So if you take in calcium and you don't have vitamin D, you're just going to pee it out because you need vitamin D for absorption. So what will happen if you don't have adequate amounts of vitamin D is you'll become calcium deficient. And this became a big deal in post-industrial Western Europe. Think about like London during the Victorian age, when you were first starting to see an abundance of coal-powered factories. They had a bunch of pollution being just shunted into the air, and it's not very sunny there anyway, right? So what you ended up with is a lack of UV radiation that was actually hitting people's skin. And then it started to manifest, especially in the children, with a lack of calcium being deposited in their bones. And it happened everywhere, but you could really see it in the femurs because, of course, you've got a lot of pressure going on the femurs. And so if you don't have a lot of calcium to put into your reinforced concrete matrix, right, what happened to the femurs of those children? Yeah, they bowed out. It's called rickets, right? And so instead of cleaning up the air, what they did is added vitamin D to the milk. And then eventually they cleaned up the air. So the reason that this is really important for you guys, and especially for those of us who are parents, is that almost everyone in the Utah Valley and the Salt Lake Valley is vitamin D deficient every winter. Why is that? There's so much pollution and inversion. And this means that you're impacting calcium availability. It's a big deal for adults, and it can manifest in depression and heart abnormalities and all that kind of stuff. It's an even bigger deal for kids because it actually impacts their growing systems. So if you have a child, especially if you have a child who's a vegetarian, my 11-year-old is a vegetarian, then you have to make sure that they're getting adequate amounts of vitamin D because there's vitamin D sources in a lot of animal products as well. So if you decide this winter to take a vitamin D supplement, you will probably be less depressed than you were last winter, okay? Probably feel a little better. The skin is also a blood reservoir, meaning that at any given point, if you're sitting around, about 5% of your blood is just like percolating through your skin. But if you get up and start working out, you need it, right? So you'll shunt it from your skin to your muscles, and you'll have like 2% of it in your skin. So you can always shunt a little bit of it away from there. And then your skin is also temporary storage for water, glucose, fats, and salts. So if, for instance, you decide you are going to chow down on an entire 1-pound bag of Doritos yesterday, you will store a whole bunch of salt and a whole bunch of water in your skin, right? And you won't be able to take off your rings, right? And you'll be like, why did all my pants shrink, right? That's what happens. You also, of course, store fats and a little bit of sugar. Okay, so before we leave this topic, now I want you to just brainstorm for a second and think about the ways in which that person that we were talking about with third-degree burns, over 60% of their body is at risk of death and disease. Like, what are they at risk of? In what ways? Go ahead. Body temperature regulation. Have you ever, burn wards are really warm because they can't control their body temperature, so you have to keep the temperature of the burn ward really warm. Go ahead. They don't have as much, yeah, I mean, mechanical damage anywhere, right? Touch anything, they're gonna hurt. What else? Dehydration, yeah.
A higher chance of cancer because there's no.
Oh, that's an interesting one. That's true too. Yeah, I hadn't thought about that. Hopefully they'll live long enough to actually have to worry about that one. But you missed the big one. What's the biggie? That's infection. Yeah, they are just big infection parties. Everything has to be sterilized in a burn ward. You don't go in without being gloved up and suited up and all of that kind of stuff. Be really careful about that. And then the last one, you may not understand if you haven't taken physiology, so I'm just going to throw it out here and you'll get it if you get phys. Okay, part of what happens is that your cells are actually sequestering certain really high concentrations of ions, including among them potassium. And if I damage thousands or hundreds of thousands of cells, all of that sequestered potassium goes into my bloodstream. If you bathe your heart with excess potassium, it can cause heart attacks. So they are really, really high risk of heart attacks because you let all of that sequestered potassium go in. So electrolyte imbalances and all of that kind of stuff is really common with burn victims. So your skin is actually good. We should be good to it. We should probably wear sunscreen a little more often. We'll talk about that in just a second. Okay, so now let's get to the layers of the integument. So what we are going to do is we're going to start superficial and we're going to do epidermis. And then we'll do dermis, and then after that, even though it's not the skin, we'll talk about it, the subcutaneous layer, okay? So epidermis, let's go to the epidermis. And the epidermis varies dramatically in thickness, right? So we looked at thin skin versus thick skin. This might be from the palm of your hand, and this might be from around your eyeball. Notice that it is dramatically different in the thickness of the epidermis between thick skin and thin skin. They're very similar in their like structural conformation, just their proportions are different. And there's one little missing thing here that we'll talk about. Okay, so the outer layer is the epidermis. And please note that even if the epidermis is thick, it's still thinner than the dermis. Do you see? Yeah, there's still more dermis than epidermis, even in thick skin. So it is composed of 4 to 5 layers. And Latin for layer is stratum. Plural would be strata, right? Anybody ever make breakfast strata? Do you make that? No? No? People, you guys are not as obsessed with breakfast as I am. It's like an egg and veggies and cheese and like some kind of like bacon layered like a lasagna, but with breakfast food. Seriously, heavenly. Okay, so 4 to 5 layers. Mostly it is keratinized stratified squamous epithelium, but there's a few cells that you haven't met before in there. So it's primarily what you expect and then a little bit of difference. Okay, so what we are going to do is we are going to build it the way that it builds itself. So this, we're looking just at the epidermis. And the epidermis, the newest cells, the baby epidermal cells will be in the bottom. The oldest ones will be in the top. And what happens is, as I make new ones, I push the old ones up. And there is a complete turnover of the epidermis about every 30 days. So you get a brand spanking new epidermis every 30 days. Does that make sense? So cell division party at the bottom, right? Dead cells at the top, slough them off. Cell division party at the bottom, dead cells at the top, slough them off. Does that make sense? So what we're going to do today is we're going to start at the bottom, right? That's where that starts. And then we're going to start moving our way up to the top and figure out what's going to happen with those. So the deepest layer of the epidermis is in contact with the dermis. It is at the what surface of the tissue? Basal. It is called the stratum basale because it's at the basal surface. Stratum, which means layer, basale, basal, right? And it's stuck to the basement membrane, yes? Okay, now the basement membrane isn't labeled there, but we know it has to be there. The basement membrane is made of sticky stuff, right? Secretions. But then in addition, this basement membrane, which we may or may not have talked about before, has what we call hemidesmosomes. So remember what a desmosome is. If these two have a desmosome together, what would happen is you would reach proteins in and grab her cytoskeleton, and she would reach proteins in and grab your cytoskeleton. That's a desmosome, right? But at the bottom, we don't have necessarily cells right under it. So what happens is those basal cells that you're seeing at the bottom, they will reach from their cytoskeleton and grab onto the fibers of the tissues below them. So do you see why it's called a hemidesmosome, a half desmosome? But not in every cell. I only have it like every 100 cells, right? So it's like spot welds every once in a while. That's going to matter when we start talking about what your skin does when you sit in the water for a long time, or blisters or things like that. So we've got sticky stuff and then spot welds every once in a while. So that's called a hemidesmosome, the spot welds that we have. And they're not drawn on here, but they're just conceptually, you can figure out what they are. Okay, so let's look at the bottom layer. So when you are looking at the stratum basale right here, it's a single layer of cells that are produced as a cohort. They're all buddies. They are all holding hands as desmosomes, right? And what happens is they're going to undergo cell division and they're going to move up mostly together. Now, I'm not saying all of them always go, but they pretty much move up as a group, okay? Now, down here, even though this is keratinized stratified squamous epithelium, the cells don't look squamous at all, right? They look like columnar or sometimes cuboidal, right? So there's a single layer, though, of these cells, and they are either called keratinocytes or basal cells. They're called keratinocytes because eventually they will produce keratin, although at this point they are not producing keratin, okay? So they're called keratinocytes or basal cells. Now, we'll address these other cells in just a second. We'll get to those. So the primary cells that you're seeing here are these purple ones, and those are the keratinocytes or basal cells. And so what is going to happen is, like I said, these will go through relatively rapid cell division. They're in epithelial tissue, and they're pretty active epithelial tissue. And as they do that, they're going to start to move up. And then at some point, remember that the nuclei will die off, right, if you're talking about keratinized, right? And when the nuclei die off, assume that all of the other organelles are done as well. But before that occurs, you will have produced a whole bunch of keratin. And by the time you've produced a whole bunch of that protein, keratin, which is a waterproofing protein, and you've killed off all of the organelles, what you're going to have at the top is a cell membrane bag that is filled with a waterproofing protein called keratin and stuck together with its neighbor with a desmosome, right? So I've got layer after layer after layer of waterproofing protein in little bags stuck together with desmosomes, okay? Now, this takes from here to here about 30 days to move up and get sloughed off and move up and get sloughed off. And as we mentioned before, what happens as you age is your rate of cell division slows down, but your rate of exfoliation is not dependent on cellular activity, right? It's just like abrasion. So that doesn't slow down and your skin tends to thin. So this, you'll get a new one about every 30 days and it'll slough off. Over the course of your lifetime, you will shed about 18 pounds of skin. Most of it is in your house and on your sheets. And you call it dust or funk, right? And you're snorting up everybody else's skin cells that you live with too. So make sure you live with people you like. Otherwise that's super grody. So you are just constantly like shedding skin cells everywhere. When I was in college, part of the way I put myself through college was working in a DNA fingerprinting and sequencing lab. And if I had the money and the time, I could figure out everywhere you were over the course of the day, because everything you touch, you actually leave skin cells behind. So why don't we do that? It's outrageously expensive and really time consuming, but it is definitely possible, which makes me think of Gattaca, right? You're just like leaving stuff, leaving evidence everywhere. So if people were really motivated, they could catch you doing damn near anything. So that's about 18 pounds of skin that you shed in your lifetime. Now, what is dandruff and what does it have to do with this story? What dandruff is that some people, both inherently and sometimes having to do with their metabolism and sometimes having to do with their genetics, people with dandruff have a rate of keratinization and therefore exfoliation that's 2 to 3 times the normal rate. Just really, really fast at this whole like producing keratin and then sloughing it off and producing keratin and sloughing it off. And that's dandruff. It's not related to hygiene. So you can have dandruff and have really good hygiene. It's impacted dramatically by whether like the air is really dry, because of course you're going to dry it out and slough it off more. You're going to see it a lot more if you have dark hair, right? And wear dark clothes. And if it's dry, it's going to be really dramatic. But what does hygiene have to do with it? If you don't wash your hair really frequently, then you're not going to get it off when you're washing your hair, right? Does that make sense? So it's going to appear more dramatic, right? So when you actually wash your hair and you do this and you do a good job of washing it and you actually get your scalp, you should get all that dead stuff off, right? So that it's not just falling onto your clothes, right? So, but dandruff primarily it's just like a different rate of keratinization. It doesn't really have anything to do with hygiene, but it's exacerbated when your hygiene is really not good. That's why, for instance, if you've ever dealt with a homeless population, a lot of times you see a lot of dandruff because they don't really have the opportunity to clean very frequently. Okay, so that's dandruff. Now, as I mentioned, the keratinocytes are made together as a cohort, and they're stuck together by desmosomes, which means that they don't fall off usually as individual cells. They fall off as groups, and that'll be important in a little bit. Okay, so there are some other cells down there, and I want to talk about, oh, wait, actually, before we do that, let's talk about our first type of skin cancer. Okay, so by the time we get finished with this set of notes, we're going to talk about 3 different types of skin cancer. The first one that we are going to meet occurs in this layer, which is the basal, stratum basale, and so it is called basal cell carcinoma. Now, these cells already have an inherently high rate of cell division, so it shouldn't surprise you that they also have a predisposition to cancer. Okay, so of the 3 types of skin cancer that we're going to talk about, and these are not all the types of skin cancer that exist, those are the 3 that you're going to run into the most often. This one is the least likely to metastasize. Do you know what metastasize means? It's when a cancer moves from its tissue of origin into another tissue and then starts dividing again. So this is usually curable by surgical excision around 99% of the time, and it's really relatively slow to move. Can it kill you? Yeah, all cancers can kill you. So your textbook, I disagree, because your textbook only shows it in the late stages. So here's what it looks like in the late stages. You should see that if it looks like somebody dropped a chocolate drop on your skin and let it melt, right? You should notice that, but it doesn't really do you a whole hell of a lot of good to only show late stage cancer. So let's see what it looks like in the early stages when people are ignoring it. In the early stages, what it usually looks like is a shiny dome. And sometimes it's not even pigmented differently than the rest of the tissue around it. It's a shiny dome, and then as it gets more blood flow, it might get a little more red, right? But it won't necessarily be red if your skin isn't really fair, right? Because you won't be able to see the capillaries through it. So you're really not looking at pigmentation. You're looking at a shiny dome that almost looks like a zip that just never goes away. And you can't pop it, right? So it's just like there. So this is basal cell carcinoma. Now in the later stages, what happens is the edges start to get a little rough. It starts to have depressions in some places and pigmentation changes, but that's in the later stages. So basal cell carcinoma and all of the skin cancers, I want to talk about where you get them, where you are more likely to get them. And I'm talking about the United States because, of course, people's clothing and hairstyles and different things are different in different parts of the world. So let's just hold it to the United States for a second, and then you can figure out how it applies to different places. So in the United States, cancers, well, everywhere, cancers are associated in increased risk with UV radiation. And it's simply because of this relationship. UV radiation mutates your DNA. It like hits your DNA and mutates it. And if you mutate one of the genes for regulation of the cell cycle, can you see that you will lead to cancer in that tissue? Now can you see that UV radiation hitting epithelial tissues is especially problematic? Yeah? Because you're already going to go through relatively rapid cell division. Okay, so UV radiation is a mutagen, which makes it a carcinogen. And so now let's talk about where UV radiation actually hits your epithelial tissues. In the United States, if you are a man, you tend to get cancer where? Anybody know? Skin cancer. Yeah, as you start to bald, you'll get it on the top of your head. Where else? The face and the nose, right? And the hand, back of the neck, tops of the ears. And why? Because that's where UV radiation hits. And males tend to be far less likely than females to wear sunscreen. Okay? And you should wear sunscreen because ugly happens to everybody, right? You don't have to get ugly, right? Everybody should put off ugly as long as possible. And also cancer. But people tend to care more about ugly than they care about cancer, right? They're like, I'm never going to get cancer, but I've seen a lot of ugly people. Here, and of course you don't look at these places very often either, right? Males also, especially if they work outside, they tend to get them on their hands. But females are a little different because we have sort of different patterns of behavior. So in the United States, where do females tend to get skin cancers? Less on their face, right? Because most of us take a decent amount of care of our face. We'll put on a moisturizer with sunscreen. A lot of times we'll wear makeup. We wear lipstick on our lips or at least some kind of hydration. So a lot of times we don't get it here, but we do get it here. Because how many of us did not wear sunscreen here when we were supposed to? We didn't, right? We don't tend to get it here and here because of hairstyles are more common here for women to have slightly longer hair. Sometimes we do get it on our hands, and the big whammy for women in the United States, and less than in like the southern states that I'm part of, is that women tend to get skin cancers on the backs of their legs because you wear shorts and you don't look back there. After a certain age, you're just going to go, no, I don't even want to look back there. I'm just going to assume everything's fine, put on these shorts, and go, right? Because like since age 15, I haven't liked what I saw. So you don't look back there, right? So that's where women tend to get skin cancers, all three types. We're not going to get to all three types today, but we'll get to this one. We might get to the second one, but probably not. Okay, so now that's basal cell carcinoma. Now also present in the stratum basale, but not a keratinocyte, is this little guy right here. Do you see this guy? It is attached to a nerve ending. This is called a tactile or Merkel cell. This is the most superficial of your sensory capacity, which is pretty interesting. It means you have absolutely zero sensation for the entire top part of your epidermis. That is the first place that you have sensation, which is why, for those of us who needed more toys and entertainment when we were children, did you ever do this? Stick straight pins into your fingers? Yes. And then go around and torture your siblings, right? That's what you do. Why didn't it hurt? So you have to go all the way to the bottom layer to feel it at all. Why didn't it bleed? There's no blood vessels in the epidermis, right? It's avascular. That's why you can do that. Now, ever go too deep? Of course you did, right? Because you were an overachiever and it's your big brother, right? And you definitely want to torture him. So if you go too deep, you know at the very least you've hit the deepest layer of the epidermis. And the dermis has boatloads of nerve endings. So if you hit the dermis, you're really going to know it. Okay. This is also why if you've ever had a blister, and I know that you have, so you went hiking and you wore the wrong shoes and you got a blister, right? What happens is with a blister, you have a friction irritation, a friction rub, and your body gets pissed off at you, and what it says is, I need to build up some fluid to protect that deeper tissue, and it builds up fluid between the epidermis and the dermis, and it pulls them apart, which is why you can take a pin and you can poke the top of the blister, yes? Does it hurt at all? No, why not? What did you do when you pulled them apart? Yeah, you pulled it away from the nerve ending, didn't you? Yeah? You pulled it away from the nerve, so you can't feel a damn thing when you do that. Now, you go under that layer and touch the deeper layer. Are you going to feel it? Hell yeah, you're going to feel it down there, right? So all that happens is you irritate it, and your body's protective mechanism is to put some fluid in there, right? Okay, and the fluid's not permanent. If you irritate it repetitively, what it will start doing is building up more keratinocytes on the top, right? And you'll eventually get a callus, right? Like when you first start playing guitar, and your fingers are completely annoyed, and they get blisters, and then later on, or you play cello? Yeah. Cello. You play cello, and then your fingers eventually get calloused as heck. Yes. Are they super calloused? Yes, they are. Yeah, I bet they are. Okay, so eventually they get calloused, but that's not the first stage. The first stage is they're annoyed, right? Yeah. And you can get blistered. Okay, so those are your tactile or Merkel cells, and then with our last few minutes, let's start to meet the last kind of cell that's going to be important down there, and that's this guy right here. I told the last class that he looks like Oogie Boogie. Does he look like Oogie Boogie from Nightmare Before Christmas? Right? Oogie Boogie, yeah. And they were like, what the hell are you talking about? I'm like, you guys are too young. So Oogie Boogie, this guy right here, is a melanocyte. And melanocytes are responsible for producing a pigment that is your primary UV protection in the skin. They produce a pigment called melanin. And depending on your genetics, melanin is either brown, yellowish brown, or black. Okay? We all have melanocytes. We all have about the same number of melanocytes. But if you are genetically from an equatorial background, around the equator, yes, then your inherent rate of melanin production should be higher as an evolutionarily stable strategy. Does that make sense to you? because you're getting more direct UV radiation and you develop more inherent melanin production. No, I'm not talking about whether you tan or not. I'm talking about the color you are when you have been sitting in a dark room and you haven't been out in the sun, just your inherent level of melanin production. And that has primarily to do with your genetic history. Now, biologically, the term race is absolutely meaningless. So your population genetics is what we have to do with, okay? So these melanocytes, what they're going to do, their activity is this. So let's look, and we'll talk about the difference between inherently dark skin and inherently light skin. Here's Oogie Boogie right there. What will happen is in a person with inherently dark skin, Oogie Boogie is really active baseline. Really high inherent level of melanin production. So what's going to happen is this cell right here, it's, okay, it is going to produce little vacuoles filled with a pigment protein called melanin. And that pigment protein called melanin will be deposited on the side of the cell that gets blasted with UV radiation. Yeah? So it gets blasted with UV radiation, although it doesn't even have to be blasted. It has to know where you generally got blasted or where your genetic ancestors got blasted. So what will happen is if UV is coming in from this side, this is like putting on a dark shirt, right? And you put on a dark shirt and it bounces off the UV radiation. Does that make sense? And so what's the difference in someone with inherently darker skin versus inherently lighter skin? Let's take a woman from the equatorial region of Africa and a woman from Ireland, right? You've got your two extremes, right? A woman from Ireland. And let's assume that they were both exposed now to the same level of UV radiation. What is inherently different is the woman from the equatorial region of Africa has an inherently high rate of melanin production. She has about the same number of melanocytes, but she has an inherently high rate of melanin production. In addition, the melanin doesn't all stay down here. The melanocytes move a little more superficial and stay down here. More protective, right? The vacuoles move a little more superficial. And her melanin is more persistent than the melanin of the person from Ireland, right? So that matters. It doesn't just matter in appearances, it also matters in protection because UV is a known mutagen and therefore a known carcinogen. So what can you predict about those two women when exposed to the same level of UV radiation? Who is going to have an inherently higher predisposition of cancer? Yeah, the Irish woman if exposed to the same level of UV radiation. And why? Because the UV can actually get to her DNA, right? And in addition to cancer, I want to talk about who has more aging of the skin. These two women, both of them 60, okay? I want to know which one will have more collagen breakdown. Do you remember that UV radiation breaks down your collagen and elastic fibers? So you can have this woman with inherently dark skin exposed to the same level of UV radiation, and she can be 60 and she can look like she's 40. And you can have a woman who's 60 and she's Irish and she's exposed to the same level of UV radiation, and she's 60 and she looks like she's 75. It's basically because the people with inherently darker skin are constantly being vigilant about putting sunscreen on, but their biology puts the sunscreen on for them. Does that make sense? And later on we'll talk about sort of the genetic and evolutionary history of the changes in skin colors as you move away from the equator, because there's some interesting stuff that happens there. Go ahead.
So what about something like genetically born with a lot of freckles?
Freckles are basically your melanocytes just have an uneven patchiness. So every time you get exposed to UV radiation, you'll just make a blob of melanin instead of a smooth melanin. And freckles are inherited by single gene. They're autosomal dominant, and but they show up with environmental triggers. Go ahead.
So like in the sun, you get more freckles?
Yes. Yeah, it's just your melanocytes are patchy in their distribution, right? And so when you get hit with UV radiation, if they're patchy in their distribution, they don't make an even spacing, and it goes blobs. It's just your, remember I told you people with fair skin don't tend to have as persistent of melanin after you make it. Then the melanin eventually breaks down. and then you get exposed again, and then you start making the melanin again. That makes sense? Okay, so next time we'll talk about skin color variation and some more cancers. So, but your quiz first, and the quiz will be just a couple of skin questions, maybe 2 or 3, and then mostly muscle.